Okay, 8.1 vector and parametric equations of a line in R squared. Okay, so this is 2D. Vector equations of a line in R squared are in this form. So we denote a vector with like an R and then a vector accent over top. And what this equals is R naught. So this is a vector from 0, 0 to the point xy. Okay, plus some parameter t, which is a scalar multiple, and then times some vector m, and vector m is a direction vector with the components a, b. Okay, I actually like how they call this vector m because we're going to think of slope. Okay, so there's two ways of finding a vector equation. We're able to find it if we have two distinct points, or if we have one point and a direction vector. Now, we're going to be toggling between vector equations and parametric equations, okay? So the parametric equations of a line in R squared, it's a little bit different, okay? It's set up as x equals and then some equation that's related to the x value, and then y equals, and again, some equation that's related to the y value, okay? So we have x naught and y naught, and those 2 points are going to be from this R naught. Okay, we're just taking the different components and putting them into the different equations here. We're still going to have a parameter t, and it's essentially going to be a scalar multiple. And then we're going to have a and b come from vector m. Okay, and again, t is an element of the real number system. So the scalar multiple just has to be any number. Okay, so let's talk about t for a second. T is the parameter, which can be replaced by any real number to obtain the coordinate of a point on the line. Okay, again, for the must-haves, we need two distinct points or one point and a direction vector. Okay, if we think about this and we want to relate it back to grade 9, we're going to have some x and some y. Okay, so what essentially this is saying is we're going to start at some point. Okay, so say this point's right here. Okay, it doesn't matter what it is. It could be like 2, 2. And then what we're going to do is we're going to apply some slope onto it. So say the slope, so back in grade 9 terms, the slope is 1 over 2. Okay, we'd go up 1 over 2, plot a point. Up 1 over 2, plot a point. Up 1 over 2, plot a point. Okay, we could also go down 1 over 2, plot a point. Down 1 over 2, plot a point. Okay, so when we're actually creating the equation of a line in R squared, it's very similar to like what we did in grade 9, but now we're going to first locate the starting point. Okay, and this starting point is just in the form x naught comma y naught, okay, the initial number that we're going to start at. Okay, we always needed that when we were graphing, say, in grade 9. And then we're going to apply a slope. Well, instead of the slope now, we're going to use a direction vector. It's going to tell us the direction that we need to go. Okay, so if this point, this may have the parameter t equals 1 because we're applying the direction vector once. Now, if we go extend to here, this one may have t equals 2 because we're applying the direction vector twice. T equals 3 would be the entire thing. We're applying the direction vector 3 times to that first point. Okay, it could go the other way as well. We're going to apply the direction vector t equals -1 or t equals -2. Okay, you can also do like a fraction. Okay, remember the parameter t just needs any real number. Okay, so let's just do a recall. A direction vector is a non-zero vector. So direction vector is going to be in the form vector m. Again, think slope. Okay, a comma b. Vector m is going to tell us what direction it's going in, where it's going. Okay, so a direction vector is parallel or collinear, okay, to the given line represented with its tail at the origin, 0, 0, and its head at the point a comma b. The A and B of the direction vector are also called the direction numbers. Okay, I personally don't use that often, but you may see it. Okay, and then a note, the direction vector may be multiplied by a constant, right? That's going to be our parameter, okay, to ensure that both direction numbers are integers. Okay, so just throwing this out there, vector M equals 1, 2. 1, 2 in that direction is going to be the same as -1, -2. Those are equivalent. And we're going to get more into that. So example 1, okay, a line passes through points P4, 3, and has the direction vector M equals -7, 1. Okay, sketch this line. So for A, so we have a point 4, 3 and a direction vector -7, 1. Okay, so I'm going to draw X and Y, my X and Y axis. Okay, and I want to point this out. So -7, 1. Because this is a direction vector, remember this direction vector, for example, -7, 1, this was the direction vector basically relocated at 0, 0. So this is the direction that we're going in. So because this is essentially like finding the slope with 0, 0, what ends up happening is I'm gonna show you what this is how it pertains to the slope. Okay, so the slope is delta y over delta x, which is 1 minus 0 over -7 minus 0. Okay, this is the slope. If you think if we had a point here and a point here, right, on either end of that direction vector, we're going, the rise is -1, that means we're falling, and the run, okay, is 7. So -1 over 7. So here's how it pertains to the direction vector. This is A, B. So this is A in the denominator and B in the numerator. That's what that looks like. So if we went over here to our Cartesian plane, we would plot the point 4, 3. That's just a number, okay? So let's go ahead and plot that point. And then we're going to go ahead and apply this direction vector. So we have the direction vector. If you want to think about it as slope, it's -1 over 7. So 3 goes to 2. That'd be -1. Okay, over 7. 7, 8, 9, 10, 11. This would go all the way to 11. And that's where our next point would be. Okay, and as long as we put arrows on both ends, we don't actually have to put that point. Okay, so the actual points we don't have to put. As long as we put arrows on both ends, we can see that this is a line. Okay, B. A line passes through these 2 points, A and B. Determine the direction vector for this line and write it using integer components. Okay, so we're essentially going to find vector AB. So direction vector AB is going to be B minus A. So for the X components, we're going to go 3/4 minus 1/2, comma, and then for the Y components, we're going to go 1/2 minus -3. Okay, this is just math. So we have 3/4 minus 2/4, right? Common denominators. And then 1/2 plus, because negative is a plus. And then 3 to be over 2 is 6 over 2. So we get 1/4, comma, 7 over 2. So this is technically vector AB. Now, this question asks us to use integer components, which is way nicer than using fractions. So if we think in our heads, how can we get rid of the fraction? Okay, what scalar multiple can we multiply this by? So we'd have to multiply this by 4. Okay, so we get 4 times 1 over 4 is 1. And then when I think 4 over 2, those will cancel to a 2 in the numerator. So I get 14. So these two direction vectors are equal. Okay, if we're thinking how are these equal, okay, think of a Cartesian plane. This is going to be delta x, this is going to be delta y. Okay, so wherever we start, say we just start at 0, 0, just for the original direction vector, if we go up 14 over 1, we have this. Okay, it's going to be equivalent to if we went up 1/4 over 7/2, we might just get this direction vector. So it's just a scalar multiple of our original direction vector. Example 2. Determine the vector and parametric equations of a line passing through this point with this direction vector. Okay, so we have the point A, 1, 4, and direction vector -3, 3. Okay, so if you remember, we're going to have vector r equals, okay, r naught, which is just a point, plus some parameter t times vector m. So all we have to do is sub in our point, which is 1, 4, and then plus t, and we're going to sub in our m, which is -3, 3. Now, the way we write out the parametric equations is we take all the information from the vector equation. So parametric equations are going to be x equals and y equals. And what we're essentially going to do, and I'm going to do the x in green, what we're going to do is we're going to pull out all of the components of x. So the 1 is a component of x, so we go 1 plus, okay, because we have a plus sign. And this -3 is also a component of x. So instead of having 1 plus 3, it's going to be 1 minus 3, and then it's t, because that -3 has a parameter on it. Now, I'm going to do the y in this red. So we'd start at 4, and then we have a 3 in the direction vector, so it's plus 3t. Okay, so this is going to be a vector equation, and this is parametric equations. All right, B says, sketch the line and determine the coordinates of 4 points on the line. Okay, so let's go ahead and sketch the line over here, and then I'll do the work beneath. Okay, so I have the Cartesian plane, x, y, and I'm going to start with plotting 1, 4. Which can be plotted right here. Now, we want to apply the direction vector -3, 3. If we remember, this is A, B. So, direction vector -3, 3, this is going to be our delta x, and this is going to be our delta y. So it's as though we have a slope of 3 over -3, which is just -1 over 1. Right, simplified? So we're going to go down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, and keep going. We can do that in both directions. So this is just a quick sketch of what that line looks like. And now let's find 4 points on the line. So we can use either the vector equation or parametric equations, and all we have to do is sub in different parameters for t. So let's do the example where t equals 1. So we want to take the vector equation and we want to sub in t equals 1, which is our parameter. So we're going to get 1 comma 4 plus, okay, we're going to sub in the 1 and get negative 3 comma 3. So here's the tricky part. We're essentially, like if we choose to take the vector equation and complete the calculations in the vector equation, then we have to take this t and multiply it by both the a and the b. Okay, and essentially what we're going to do is we're going to have to break it down into parametric equations, and it's going to have to happen in our heads. So that this is one way of doing it. We can say, okay, so for the x component, we're going to have 1 plus 1 times negative 3, so minus 3, which is negative 2. And then for the y component, we're going to have 4 plus 1 times 3, which is 3, so that's 7. Okay, so a point on this line is going to be negative 2 comma 7. Okay, that's going to be approximately here. Okay, if you don't like to read it from the vector equation and then visually break up the x and the y's, we can always do the same thing, but with the parametric equations. It may actually be easier. So let's do the parametric equations, but let's do them with t equals 2. Okay, so this time the parameter is 2. So our x component is going to be 1 minus 3 times 2, right? Straight from this parametric equation. Our y component is going to be 4 plus 3 times 2. I'm just going to put the equals beside. I didn't leave room. So 1 minus 6, we get negative 5. And 4 plus 6, right? 3 times 2 is 6. Is going to be 10. So another point on the line is negative 5 comma 10. Okay, negative 5 comma, and then 10 is going to be up here somewhere. It's going to be here. Okay, let's do one more of each. So let's go, what about t equals negative 1? Okay, let's try a negative parameter. So we'll do vector equation. So vector r equals 1 comma 4 plus, this time we're going to do negative 1. And then we're going to multiply it by the direction vector. Okay, so we're going to go negative 1 times negative 3 and negative 1 times 3. So component form, this is going to be 1 plus negative 1 times negative 3, which is 3. Okay, which is 4 comma. And then we're going to have 4 plus negative 1 times 3, which is negative 3. So 4 comma 1 is also going to lie on our line. Okay, up here, that would be approximately 1, 2, 3, 4, 4 comma 1. Okay, let's do an ugly parameter. Let's do the parameter, let's do 1/3. I'll show you why I was thinking 1/3. Okay, let's talk about parametric equations. For the x, we have 1 minus 3t, the 1 minus 3 and 1/3. Okay, so 3 times 1/3 is just going to cancel to 1. 1 minus 1 is 0. I picked 1/3 because I know the direction vector has negative 3 comma 3. So both are divisible by 3. So I made it a little hard, but then I made it a little easy. Okay, and the y, the parametric equation for the y value is going to be 4 plus 3 times 1/3. Again, 3 times 1/3 is 1, and we get 5. So this coordinate is 0 comma 5. Okay, which is going to be right here. Okay, now C. Is the point Q negative 21 comma 23 or the point R negative 29 comma 34 on this line? So essentially, these are two completely different questions, okay? So coming down here, I'm going to say, we're going to do C down here, okay? So if we think about our parametric equations, and I'm just going to rewrite them so we have them handy, x equals 1 minus 3t, y equals 4 plus 3t. We're going to test 2 points, okay? So for the first one, we're going to test the point negative 21, comma 23. So what we want to do is like, this would be the x and this would be the y, essentially. Okay, so let's plug in negative 21 to the x, and then 1 minus 3t. And then what we're going to do is we're going to plug in the y, 23, 4 plus 3t. And then what we're going to do with both of these, because these are just equations with one unknown, we are going to solve for the parameter. Okay, so what our question actually is there some parameter that we can sub in order to yield this point Q? So let's rearrange. So then we'll have negative 21 minus 1 equals negative 3t. So negative 22 equals negative 3t. And divide both sides by negative 3. We get t equals negative 22, or 22 over 3. Okay, so when we come over here, we have to say, okay, was the same parameter subbed into like the y, or the parametric equation for y, in order to get 23? So let's solve for this. 23 minus 4 equals 3t. I get 19 equals 3t. Divide both sides. I get t equals 19 over 3. So since these have different parameters, there's no one parameter that we can sub in to these parametric equations in order to get Q. So therefore, Q is not on the line. Now we're going to do the same thing for the point R, which is negative 29, comma 34. So let's sub in negative 29 equals 1 minus 3t, and then we're going to have 34 equals 4 plus 3t. Okay, I'm going to start skipping steps. So bring the 1 over, we get negative 1. So we get negative 30 equals negative 3t. Divide out the negative 3, and we get t equals 10. Now, bring over the 4, we get negative 4. So we get 30 equals 3t. Divide by 3, and we get t equals 10. Okay, therefore R is on the line. What this means is that we have some parameter, and our parameter is 10, that when we sub it into the parametric equations, it will yield this point R. So our line will pass through R, it will not pass through Q. Example 3, determine a vector equation for the line perpendicular to this line here. Okay, and passes through the point P 6, 5. So we have two pieces of information. We have, when we talk about perpendicular, you're thinking slope, okay? You're thinking direction vector. Then we're thinking point for 6, 5. So let's do perpendicular to this first. So the direction vector in this equation is negative 3, 2. The rest of the information in this equation doesn't matter. And just to highlight this, the parameter for this one is S instead of T, and that's okay. You're going to see a lot of S's, a lot of R's, and a lot of T's. So if this is A, comma B, in other words, again, if this is delta X and then delta Y, our slope would be B over A. Now, when you're thinking perpendicular, okay, you're thinking perpendicular would be negative A over B, okay? They're negative reciprocals. And all that means is that we've negative changed this B over A to negative B, it would have been negative B over A. And then we take the reciprocal. So we take B over A and we flip it. Okay? So when we're thinking of vector M, what is our vector that's perpendicular? Let's just call it direction vector 1. Okay? So instead of negative 3, 2, we're going to flip these. And we're going to get 2, 3, or even negative 3 if you want to go literally. And now what we have to do is we have to take the negative of one of these. Okay, remember the negative is on the entire number. So all we have to do is switch one of these signs. So let's go positive 3. So our direction vector that's perpendicular to this vector equation is 2, 3. Okay, now it gives us a point. And we know from the original directions, all we need is a direction vector and a point, and we're golden. So let's write the equation. Vector r equals, we write the point first, which is 6, 5. Okay, plus some parameter. You can say s, you can say t, it doesn't matter. I do like t. Okay, and then we're going to put our new direction vector, which is 2, 3. And we can always say t is an element of the real number system. Example 4, determine the vector and parametric equations for the line containing these 2 points. Okay, so this is the other situation where we can find the vector and parametric equations, okay, when we have 2 points. So we know that we need 2 things. So we know we need a direction vector, and we know we need a point. So for the direction vector, let's find direction vector EF. So what we're going to do is we're going to take F, and we're going to subtract E, okay, the components. So 6 minus negative 1 would be the x's. Okay, and then 11 minus 5. So we have 7, 6. Okay, and that's our direction vector. Now, we already have a point. We actually have 2 points. So you can choose either point you want to use. Okay, you can choose E or F. It doesn't matter. Okay, I like to go with positive numbers. So let's go 6, 11. But it doesn't matter either way. So the vector equation of this line is vector r equals point 6, 11 plus t 7, 6. Okay, now we can take the vector equation and we can break it down into parametric equations. So we're going to have x equals and y equals. Okay, we're going to have x equals 6 plus 7t. Right, we're taking the first component of each of these. And then for the y, we're going to have 11 plus 6t. And these are our parametric equations. Now B, what are the coordinates of the point where the line crosses the x-axis? Okay, so if you think about this visually, the x-axis, wherever it crosses here, the y value, like we're going to have a height of 0. So it's going to be some number x, 0. Okay, that's why whenever we find the x-intercept, we sub in y equals 0. Okay, so let's talk about this. I'm going to pull the parametric equations. So we know one of the coordinates. We know the y coordinate. So let's pull the parametric equation for y. Y equals 11 plus 6t. We know that the y is going to be 0. So what we can actually do is we can find the parameter that yields a 0 for the y value. Okay, I'm going to move this 11 over. I get negative 11 equals 6t, and then divide both sides by 6. So we're able to get a y of 0 when the parameter equals negative 11 over 6. Now, we want to find the x. We don't know what the x is. So let's write the x parametric equation. 6 plus 7t. Okay, let's go ahead and sub in negative 11 over 6 for the parameter. Okay, so we're going to have x equals 6 minus 77 over 6. Okay, if you want a common denominator, we're going to multiply by 6 over 6. So 36 minus 77 is going to give us the x value of 41 over 6. Okay, so what we did is sub in y, solve for t. And then what we did over here is sub in t, solve for x. So our x value here is negative 41 over 6. Okay, so therefore, the x-intercept, or yeah, we can call it x-intercept, that's fine, is negative 41 over 6, comma 0. All right, C. Can this equation here also represent the line containing points E, F? Okay, so let's go down here. We're going to write C. All right, I'm just going to rewrite vector R. So negative 15, comma negative 7, plus T, 14 over 3, comma 4, and T is an element of the real number system. Okay, all we're actually doing in this question is checking if E, which is negative 1, 5, and F, which is 6, comma 11, are on this line. Okay, if both of these points are on this line, like in 2D, if we have 2 points, I'm just going to go negative 1, comma 5. So if we had E, and then 6, comma 11, if we had F, all you need is 2 points in order to actually solve for the equation of the line. So let's break this down into parametric equations. Okay, so negative 15, negative 7, I actually usually stack them like this. Negative 15, negative 7. Okay, those are the two components for the point. Now, plus, this is going to be 14 over 3t, and this is going to be 4t. Okay, so we're going to check E first. So let's go ahead and sub in negative 1 to where the x is. So negative 15 plus 14 over 3t. And let's go ahead and sub in the 5 to where the y is. 5 equals negative 7 plus 4t. Okay, and we've already seen this style of question. So negative 15 comes over. Negative 1 plus 15 is going to be 14. Equals 14 over 3t. We can cross multiply this up, cross multiply this down. It's essentially going to be 14 times 3 over 14. So the 14s are going to cancel and t equals 3. Now let's check the next one. Bring the negative 7 over, it becomes positive 7. 5 plus 7 is 13. No, 12. Okay, equals 4t. Divide both sides by 4. we again get t over t equals 3. Okay, so this line up here, R contains the point E. That's at the minimum. Now, let's check F. We're going to do the exact same thing, but with 6 and 11. Okay, so 6 equals negative 15 plus 14 over 3t. And 11 equals, okay, negative 7 plus 4t. And let's solve. So negative 15 comes over, it becomes positive 15. So 15 plus 6 is 21 equals 14 over 3t. Okay, cross multiply the 3 up. Cross multiply the 14 down. Okay, essentially we get 21 times 3 over 14. And we're going to end with t equals 4.5. Okay, next one. Bring over the negative 7, we get positive 7. So 11 plus 7 is going to be 18 equals 4t. Divide both sides by 4, and we get t equals 4.5. So this also contains, let's go, R contains F. So when we're thinking of the answer, going back up to this question, the question is, can the equation, this, also represent the line containing points E and F? Okay, our answer is yes.